Hello everyone, welcome back to RESHMI'S Corner. Today we are discussing about the topic real numbers, which is the first chapter of 10th grade CBSE NCERT. Now before we go on to real numbers, let's first have a revision on what the numbers are. Let's start with the natural numbers. What is a natural number? Natural number is a set of all numbers starting from 1, and we denote the set of all natural numbers as n. N is equal to set of all numbers starting from 1. So 1, 2, 3 and so on. This denotes the set of all natural numbers. Now what if we add a 0 to this set of all natural numbers? What does that become? We call that set as W, which is a set of whole numbers, and that is 0, 1, 2, 3 and goes on. And this set we call it as the set of all whole numbers. Now these set of natural numbers are also called as the positive integers. Now what if I represent this set in a number line? So I draw a number line 0, 1, 2, 3 and so on, and I'm going to write the negative integers also on the number line. So that becomes -1, -2, -3 and so on. Now this set of numbers which contain all the negative integers along with the positive integers and 0 is known as the set of all integers. So I can write it as -3, -2, -1, 0, 1, 2, 3, so on. Now, what are real numbers? The simplest definition of real numbers is real numbers are those set of numbers which can be represented in a number line. So see, for an example, 0, I can represent it on a number line. I can represent 2 on a number line. I can represent all negative numbers on a number line. What if I'm asked to represent 0.5? I can represent it on a number line. It lies somewhere between 0 and 1. What if I'm asked to represent -2.5? It lies somewhere between -3 and -2. I can represent it on a number line. So all the numbers which I can represent on a number line are called the real numbers. Next, we move on to the Euclids division lemma. So let's see what this Euclids division lemma is. Now, what is this Euclid division lemma? According to Euclid division's lemma, if A and B are any two positive integers, if A and B are any two positive integers, then there exists a unique whole numbers Q and R such that A is equal to BQ plus R, where 0 less than or equal to R less than B. Now alternatively you can write this as dividend is equal to divisor into quotient plus remainder. So here A is called as the dividend, B is called as the divisor, Q is the quotient and R is the remainder. Now this Euclid division lemma leads us to Euclid division algorithm. So now let's see what this Euclid division algorithm is. So what is this Euclid division algorithm? As we said before, using the Euclid division lemma, we get the stepwise procedure to find out the HCF of two positive integers. So let's see what this algorithm is. Using the Euclid's division lemma, you get the stepwise procedure for finding the HCF of two positive integers A and B, where A is greater than B. So this is our Euclid division algorithm. Now what are our procedures in this algorithm? Let's see what are our procedures. First one is applying the Euclid division lemma. What is our Euclid division lemma? If A and B are two positive integers, then there exist two unique whole numbers Q and R such that A is equal to BQ plus R, where 0 less than or equal to R less than B. Now this is our first step in the Euclid division algorithm. Now here when we substitute our numbers A, B, we get two whole numbers Q and R. But if our remainder is 0, then what happens? That is our second condition. If R is equal to 0, then the HCF of A and B is equal to B. But what if our remainder is not equal to 0? And if our remainder is not equal to 0, then we repeat Euclid's division lemma for B and R. And we continue this procedure till we get our remainder 0. And there comes a step when we get the remainder 0, and that divisor will be our required HCF. So that will become our third condition. That is, when we get R equals 0, then the divisor in that particular step will be our required HCF. So what is the Euclid division algorithm? It is the stepwise procedure to find out the HCF of two positive integers A and B, regarded A should be always greater than B. Now let's discuss a few examples using this Euclid's lemma and Euclid division algorithm. Now this is our first example, which is to find the HCF of 237 and 81. Now using this Euclid division lemma, let us find out the HCF. What is our first step? You divide 237 by 81 to check whether we are getting our remainder 0. So 81 2s are 162 and we get the balance 75. So here again we haven't got our remainder 0, so we perform the division once again. So here 81 becomes our dividend and 75 becomes our divisor. 75 ones are 75, balance 6. Again we haven't got a remainder 0, so we again perform the division. So here 75 becomes our dividend and 6 becomes our divisor. 6 12s are 72 and we get the balance 3. Again we haven't got the remainder 0, we again perform the division, where 6 becomes the dividend and 3 becomes the divisor. Now 3 2s are 6 and finally we get the remainder 0. And the divisor at this step where we get the remainder 0 will be our HCF. Therefore, our HCF of 237 and 81 is equal to 3. Let's move on to the second example, example 2. Now, this is our second example, which is to find out the HCF of 91 and 26. So, how do we start? We divide 91 with 26. 26 3s are 78, we get the balance 13. Now here again we haven't got a remainder 0, so 26 becomes our dividend again and 13 becomes our divisor. 13 2s are 26 and here we have got a remainder 0, then that divisor will be our HCF. Therefore, HCF of 91 and 26 is equal to 13. So this is how we find out the HCF using the Euclid division lemma and Euclid division algorithm. So that was for today's class. See you in the next class. We'll start with our exercise 1.1. Till then,